Hi, and welcome to another installment of Math Basics with Mr. Besh. Today we talk about the Pythagorean Theorem. It is a very useful as well as powerful tool in geometry. The Pythagorean Theorem lets us find a missing side of a right triangle. Now remember, the Pythagorean Theorem only works with right triangles. This is the demo or model that we're going to be using. My right triangle here. The three sides of my right triangle are labeled as follows: A, B, and C. Notice that C is directly across from my 90-degree angle measurement, which I've shaded in pink for you. My other two sides of the triangle, the height, which is labeled as A, and the base will be labeled as B. Sides A and B are known as the legs of a triangle, where side C is always known as the hypotenuse. If I compare these three sides, I want you to notice that the hypotenuse is always the longest side. A and B, sometimes A can be bigger than B, sometimes B can be bigger than A, sometimes they can be congruent values, but C will always be bigger than either A or B. The formula for the Pythagorean Theorem is A squared plus B squared equals C squared. And what this means is when I take the value of A times itself and then add it to the value of B times itself, it needs to equal the value of C times itself. The last step I need to do every time when dealing with the Pythagorean Theorem is I need to take the square root of the value. Make sure you find this button on your calculator. My first example 4. What I'm trying to do is I'm trying to find C. What I know is the A value, which is 3, and the B value, which is 4. I plug them in my formula, and I do a little calculations, and I get 3 times 3, which is 9, plus 4 times 4, which is 16, and that comes out to be 25. Last but not least, I need to take the square root of 25, and the square root of 25 comes out to be 5. The square root means what number times itself makes 5. Some of these you're going to know off the top of your head. Others you're going to need the calculator for, especially when you get to decimal values. Example of this. Again, I know A and B, but I do not know C. So I plug them into my formula exactly the way they are. Do a few calculations. 6 times 6 gives me 36, plus 11 times 11, which is 121, and together they add up to be 157. This time, when I take the square root of 157, I get 12.53, nicely rounded. Not all the time when you use the Pythagorean Theorem are you trying to find C. Sometimes you're trying to find A or B. So now what happens when this is done is that there's always one extra step involved in the process. I still plug them into the formula the same way. Notice, the largest side C is always by itself on the right-hand side. When I do my calculations this time, the extra step is I need to take either the A or B value that I find and subtract that from the C squared value that I get on the right hand side. So notice, 25 times 25 gave me 625 on the right hand side. On the left, B, 20 times 20 gave me 400. I have to take the C squared value, which is 625, minus the B squared value, which is 400, and get 225. Notice I color coded them for you. 225 is the value of A times A. My last step in the Pythagorean Theorem is to take the square root, and the square root of 225 gives me 15. My last example works the same way, except this time I'm trying to find B. Exactly the same as the last time. Plug them into my formula, this is what I have. Do my calculations. On the right hand side, 30 times 30 makes 900. On the left hand side, 12 times 12 gives me 144. When I take 900 minus 144, I get 756. And last but not least, I take the square root of that, and the square root of 756 is 27.5. And this is the Pythagorean Theorem. I hope you guys find this both helpful and informative.